Very good afternoon to all. Once again, I welcome you all for this our today's second lecture. Okay. In the first lecture, we have discussed about our rotary pneumatic cylinder, that is air motor. Getting it? And at the end of last lecture, we have started our unit number 5, that is a pneumatic system component. In that, we are going to discuss the valves, compressor, FRL unit. Okay, and at last, we are going to discuss the direction control valve, flow control valve, and pressure control valve. Now, let us start with the first point, or the most important element of the pneumatic system is the air compressor. Okay, so as we all know that majority of as we know that majority of this pneumatic systems are uses compressed atmospheric air as a working medium. Getting it? Because as we know that every pneumatic system uses atmospheric compressed air as a working medium or as a working fluid, and the performance of this pneumatic system and its component, okay, are mainly depend on that compressed air supply. Getting it? So the compressor, as we know that compressor compresses the atmospheric air into the compressed air. Okay, because in the compressor is taking atmospheric air as an inlet, then inside the air compressor, air is going to compress, and at outlet of air compressor, you will get compressed air. Getting it? And that compressed air further supplies the to the your actuator or the further where we need to perform the useful work. Okay, so that compressed atmosphere is compressed into the compressed air at a compressor, and it supplies that necessary quantity of air with required pressure. Okay, in that air compressor itself will have the pressure gauge, and at that pressure gauge you will get the pressure rate or pressure rating of your compressed air. Whatever the quantity of air, compressed air, you require at the time of that actuator, or that at the time of useful work, that much compressed air you can take from your compressor. Okay, and at whatever the required pressure, no, at that pressure you can take. Okay, so that is a compressor, and before that compressed air is being supplied to the other circuit component, no? So that time it should be uh, conditioned or processed so that you can achieve better performance, and that compressed air should be safe for the operation. That you have to make clear, okay, before supplying to the your that actuator or your that further system. And for that purpose, whether your compressed air is clean or whether it is safe at condition, okay, whether it is as a safe condition, that you need to clear. Getting it? And for this purpose, fluid conditioner such as your filter, then lubricator or a regulator or the muffler and air dryer, that elements are required in the pneumatic system. Okay, because in the pneumatic system we know that the compressed air is required, and that compressed air we get from the compressor. Okay, and in the compressor, air is atmosphere air is taking inside and it is compressed. But that compressed air, whether it is conditioner or processed or not, that we should know. and to condition or to process that air, we should have filter, regulator, lubricator, muffler, and air dryer. That element in the any every pneumatic system. Okay, and in this topic or in this chapter, in number 5, we shall discuss the purpose of the air compressor, construction, working, operation of various types of the compressor, and then we are going to going for fluid conditioner. Now fluid conditioner means what? FRL unit, filter, then lubricator, regulator, FRL. Okay, and air dryer. That are the filter, regulator, lubricator, and air dryer. So that is the combination of one unit. Okay, and that is called fluid conditioner. Okay, now once again we'll start with the one basic question, that is a what is a compressor. Okay, what is a compressor? So the compressor is a device which is used to compress air or any gas. Okay, in the pneumatic we are taking air as a working medium, so due to that only here I am using a word, the device which is used to compress the air from low pressure, that is low inlet pressure. Usually that pressure is around atmosphere pressure, and from that low inlet pressure you need to compress to a higher pressure level. Okay, higher pressure, desired pressure level. Okay, and that device is called the compressor. And in pneumatic systems, compressors are used to compress and supply the required quantity of air. Okay, not to only compress the air, but along with the compression of that air, the purpose of this air compressor is to supply the required quantities of the air to the further circuit. Getting it? And as per the law of perpetual gas, the compressor increases the pressure of the air by reducing its volume. Because just we know that we get that compressor is going to compress the air. Getting it? Or it increasing the pressure. But how the air, pressure of the air is going to increase in the compressor? So for that purpose, we know that as per the law of perpetual gas, compressor increases the pressure of the air. How? By reducing the volume. That is the basic fundamental of the air compressor. Now, this air compressor is mainly divided into the two types of the air compressor. Okay, so there are two basic types of air compressor, and that is again based on their method of energy transformation or energy transfer and pressure generation. Okay, based on their method of energy transfer and pressure generation, the air compressor is divided into the two types, and they are, one is the positive displacement type compressor, and second is the dynamic type compressor. Now again question arises is that what is positive displacement type compressor? So these positive displacement type air compressors works on the principle of increasing the pressure of a definite volume of air. Once again, I am repeating, this piston positive displacement type air compressor work on the principle of increasing the pressure of a definite volume of air, increasing the pressure of a definite volume of air. How that pressure increment will happen? By reducing the volume in a enclosed cylinder or in a enclosed chamber. That principle, if it is applied, then it is called the positive displacement type compressor. Pressure in the air, it is increased or it is induced by mechanically reducing its volume. Getting it? It is called positive displacement type air compressor. And second is a dynamic type. So dynamic compressor are also known as a turbo compressor. Okay, it is also known as the turbo compressor. And these dynamic compressors employ rotating vanes or impellers for what purpose? To increase the pressure of that air. Okay, dynamic type of air compressor uses the rotating vanes or impeller to increase the pressure of the air, and that pressure in the air, that is actually it is increased by dynamic effect. Now what is that dynamic effect? That is mean imparting motion to the your air, and later that converting motion into the velocity into static pressure. Getting it? That is called the dynamic type air compressor. Okay. Now here I have shown all the types of the or classification of the compressor. You can see the compressor is basically divided into the two types. It is based on the method of energy transfer and pressure generation. First is the positive displacement type, and second is the dynamic type. Now further this positive displacement type air compressor, it is divided into the further two subtype. One is the reciprocating type air compressor and rotary type air compressor. And again, reciprocating type air compressor divided into three types. One is the piston type, then labyrinth type reciprocating air compressor, and diaphragm. Okay, we are going to discuss this piston type. Then this rotary positive displacement type air compressor is further classified into five types. One is the screw type, then vent type, lobe type, liquid ring type, and the gear type. Okay, so these are the five types of the rotary positive displacement type air compressor. Getting it? And the second category, that is a dynamic type air compressor, it is divided into the divided in a centrifugal groove. Centrifugal air compressor again further divided into the radial flow air compressor and axial flow. Okay, so these are the types of the air compressor. In detail we will discuss further. Okay, please have a look on the screen. The detailed slab classification of air compressor I have shown in this schema in this table. Okay, so however for the study we are going to discuss the piston type, screw type, vent type. Piston type is what that our single type reciprocating or double cylinder or double stage single stage double stage. Okay, that is a piston type reciprocating air compressor that we are going to discuss. And in the rotary type we are going to discuss the vent type rotary air compressor, screw type, and lobe type. Getting it? For the study purpose, that compressors type we are going to discuss in detail, and that are these compressors only are more important from a subject point of view and as per the curriculum point of view. Okay, whether voice is audible, whether everything is okay at your end, let me know in the chat box. You can write yes, no. Please tell me whether everything okay at your end. Now let us discuss that first one. Now we came to know that what is meant by compressor, what is its purpose, how this positive displacement type categorized and dynamic type, and this classification. Now one by one in detail we'll discuss. So firstly we'll go for this piston type reciprocating compressor. Okay, piston type reciprocating compressor. Okay, so this is a schematic diagram of piston type reciprocating air compressor. Piston type reciprocating compressor. Okay, please remember that this compressor, it is not present in the hydraulic system, and pump is not present in the pneumatic system. Okay, but the function or the purpose of pump in the pneumatic hydraulic system and purpose of compressor in pneumatic system. Okay, please remember that. So here air compressor is the energy conversion element. Okay, in this pneumatic system, what they do, they impart mechanical energy to your air by compressing it. Okay, that means the main difference between your pump and compressor is that fluid delivered by the compressor is the air that is compressed, and again that is under pressure. At the time it is delivered, no, that time it is under pressure. Okay, even if there is no further load on that system, then also at an outlet of the compressor you will get the pressurized air only. Okay, getting it? So please remember and remember that difference between the pump and the compressor. Please tell me what is the difference between the pump and compressor. In the chat box also you can write on your answer. Please tell me difference between the pump and compressor. Pump and the compressor. Pump and compressor. Please tell me. Pump and compressor. Please tell me. Then we'll go in detail. Basic difference. Pump and difference. Sorry, pump and compressor. Pump, here one answer I got. Pump we use in hydraulic. Okay, and compressor is that is clear, basic. Pump it is used in hydraulic system and pneumatic. In the pneumatic system, compressor used. But what is the purpose in the hydraulic? Purpose of the pump in the hydraulic and purpose of compressor in the pneumatic. That tell me. Be fast. Tell me the main difference between the pump and compressor. Please tell me. What is that difference? I have told you. What is the difference between? Nobody giving answer. Please give me answer. Then only I will proceed further. What is difference between the pump and compressor? Be fast. In terms of energy conversion, also you can tell me. In terms of energy conversion, which energy is converted to the in which form of energy, that you can tell. In pump, what happened? And in compressor, pump move liquid and gas. Gas is not used in pump. Pump have the ability to move liquid and compress move gas. Azon. Both are the energy conversion element. Pump and compressor. Pump, it is used in the hydraulic system. Okay, and in the pneumatic, compressor is used. It is compressing the air. That means from which energy the energy is converted, or inlet energy. Which type of inlet energy is used for pump and compressor, and at outlet which kind of energy you will get. In that terms also you can tell me. Okay, please remember this question. Okay, at the end of this lecture, once again I will ask. Okay, so I was telling about this piston type reciprocating compressor. Okay, reciprocating type air compressor. Okay, normally this piston type compressor, the reciprocating compressor, are the most commonly used compressor in the fluid power industry. Getting it? And the construction, if you see the diagram, no, already you all learned the IC engine subject. So the construction, if you see the this schematic diagram, then you will come to know that the construction and working of the this piston type, reciprocating type air compressor is very much similar to that of our internal combustion engine. Okay. So what is its construction? So here, with the help of this schematic diagram, I will explain. So you can see the this schematic diagram. So this is a typical piston type reciprocating air compressor, and it consists of a cylinder. You can see this is a cylinder. Okay, this is a cylinder. Head is there. Okay, here. Okay, upper side of this inlet and outlet wall. Okay, that is a cylinder head. Then piston with piston ring. This is a piston and piston ring. Getting it? Inlet and outlet port or delivery wall, you can call inlet wall and outlet or delivery walls. Okay, then this is a connecting rod. Getting it? This is a crank. Please check. This is a crankshaft. Okay, getting it? So the arrangement of this basic single acting, you can call, or the piston type or reciprocating type air compressor. Here you can see. Okay, now how it operate, that basic question arises, and we know that the whatever the how IC engine works, that we know that. So same way here is there. So first this prime mover. Okay, that means your electric motor. Okay, mostly a prime mover means what? Your electric motor, it is used for what purpose? That prime mover or the electric motor, it is used to drive this compressor unit. Getting it? And that electric motor normally supplies the rotary motion. Getting it? Because we know that the shaft, crankshaft of this compressor, it is normally connected to the our, or maybe it is connected by the belt and pulley arrangement to your electrical motor. Getting it? So that motor, electric motor or the prime mover, you can call, it supplies the rotary motion to this crankshaft of your reciprocating air compressor. Okay, and which in turn convert that rotary motion, it in turn converted into the reciprocating motion of this piston. Okay, rotary motion of your crankshaft. Due to that reciprocating motion of the piston through this crank and connecting rod arrangement, it is possible. Getting it? Reciprocating motion of this piston will possible due to the rotary motion of the crankshaft, and that rotary motion from where you will get? From the prime mover. And prime mover means what? Electrical motor. Getting it? Now how it works or how it operates? So during the downward motion of this piston, no, now this is idle at exhaust stroke, okay, or outlet stroke is there. That is here I have shown the position. But when this during this downward motion of this piston, no, that time what happened? This inlet port will open, and through this inlet port or inlet wall, atmospheric air or the air will come inside this cylinder, and that time the piston will move in the downward direction. Okay, inside this cylinder, it falls below uh, uh, to this point. Okay, and during that, the pressure inside this cylinder, no, that will falls below the your atmospheric pressure. Okay, and inlet port that time it is open due to the pressure difference. Getting it? Then air is drawn into the cylinder until up to what? Until the piston is reaches to its this bottom end of your this stroke. Okay, bottom of your stroke. Up till that, up to when that piston will come to the your bottom of your stroke, no, up to that air will come inside the your cylinder, and after that your inlet port will close. Getting it? Then outlet or the exhaust port or that stroke will start, and as piston start moving upward, no, okay, how it is going to move upward? Due to the rotational or rotary motion of your crankshaft. Okay, due to that only piston start moving upward. Okay, and that time inlet wall is closed and pressure start increasing. Okay, this pressure will start increasing. How it is going to increase? By decreasing the volume of that air. Okay, inside your chamber or inside your cylinder, inside this chamber. Okay, and that pressure that will increase continuously up to what? Until the pressure inside the cylinder is above the pressure of your delivery. Okay, and when that pressure inside pressure of the air, when it will reach above the pressure of the delivery side, no, okay, which is normally it is which is connected to the receiver. Okay, that delivery port is connected to the receiver, and then only outlet port will open, and outlet port wall opens and air is delivered through this delivery wall or outlet wall. Okay, during the your that remaining upward motion, okay, of your piston, and that what are the air is going to deliver by this port or wall, that will go to the your reservoir. Okay, or a receiver. That is a basic working principle operation of reciprocating type air compressor. Understood or not? Understood? Understood or not? Please tell me, understood or not? In the chat box, please write your message. Yes, no. Please tell me, understood or not? Operation of this reciprocating type air compressor, it is much similar to your internal combustion engine. I think in applied thermodynamics subject also you have learned this compressor. Understood or not? Understood or not? Please tell me. Nobody is giving a reply. What is happening? Are you getting or not? Please reply me. Understood or not? Okay. Now, this is normally this is single stage our piston type or reciprocating type air compressor. Okay. Now, though this single cylinder, this is a single cylinder, no. So this single cylinder compresses the our air, and that can be provided pressure up to the 10 bar. Okay, and usually the possibility that we can further go for the multi staging or the multi cylinder. Okay, with the help of the more than 2 or 60. Okay, 2 to 16 cylinder you can connect to each other, and that is called the multi staging or the multi cylinder. For what purpose you can go for that multi staging or multi cylinder piston compressor? Okay, to increase the compression capacity, and also due to the many practical reason also you can go for the multi staging. Okay, now I will explain this two stage reciprocating air compressor, two stage type reciprocating type air compressor. Okay, you can see this is a schematic diagram of two stage reciprocating type air compressor. Okay, now so this two stage reciprocating type air compressor, this is one of the most commonly used or employed types of the reciprocating air compressor. Okay, and this may either motor or engine driven. Okay, so prime more it may be your either motor, electric motor or engine. Okay, and this type of compressor provide a moderate range of pressure and the delivery. Okay, and the schematic view of the this is actually V type design of this two-stage reciprocating air compressor. This is called V type design. Okay, and as I have shown in this figure, here you can see the construction of this two-stage reciprocating type air compressor. It is much similar to our IC engine design. Okay, two-stage reciprocating IC engine, we know that. Okay, so here you can see the two pistons are there and which are connected to the common crankshaft. Here we have the crankshaft, crank is there and crankshaft. Okay, and this connecting rod, sorry, uh, both the pistons connecting rod, it is connected to this common crankshaft. Getting it? So these two pistons, okay, are connected to your common crankshaft, such that how it is connected, such that where when there is a suction stroke no of a one cylinder, sorry, one piston, that time second piston is in delivery stroke. Okay, right? So for example, suppose this first piston, if it is at a inlet, sorry, exhaust, sorry, intake or the suction stroke no, that time your the second piston will be at delivery stroke or exhaust stroke. Okay, so like that its arrangement is there. You can see here for this first cylinder we have the inlet outlet port, same here also we have. Okay, and for the cooling purpose here we have the intercooler also. Okay, this one this first one is a high pressure cylinder, this is a low pressure cylinder. That means suction you can take from this suction filter. Okay, this is the inlet, getting it, and from this port it will get outlet. So for example, at piston number 1, if piston take atmospheric air inside and up to 10 bar, if it is compresses, then that 10 bar air will move to the will go to the your this compressor number 2. Okay, this cylinder as an inlet, and then further it's a compression will happen in the second piston cylinder. Okay, and that 10 bar will compresses, that means its pressure further increases up to 50 bar. It is called the multi-staging, or here it is a V type, that means a two-stage reciprocating type air compressor is there. Getting it? So this is a two-stage reciprocating type air compressor. Okay, now we can I will show the general diagram. You can see this is a diagram. From through this we can get external parts of this two-stage reciprocating type air compressor. You can see here we have this air receiver. Okay, that means from delivery port your compressed air will store in this air receiver. Getting it? This is your low this is your low pressure cylinder, and this is a high pressure cylinder. This intake filter is there. Okay, this guard is there. This is a prime mover, that is a electrical motor, it's base, and here we have the air outlet wall. Okay, of your air receiver. From that air outlet wall you can take air and it can be transport or transfer to the your further wall and actuator. Getting it? Here we have the safety wall. Okay, that means the pressure gauge and safety walls are there. Okay, pressure switch is there. So this type of compressor, air compressor, we have seen in many store. Okay, automobile store also. Okay, and at our workshop also we have this type of two-stage reciprocating type air compressor we have. Getting it? Now firstly we'll go for one small video for this point, and then further we'll go for next one. Okay, wait, small video I will show. Just a minute. How does this air compressor work? No, for that only. Already I have discussed, but just through this video once again as a repetition or just.
This air compressor consists of an electric motor that compresses air into a storage tank. The compressed air can be released at chosen pressure when required. How works an air compressor? What are the criteria for selecting a proper air compressor? Well, there exists a variety of different compressor types. Let's continue with an overview. Normally, the compressors used in the field of automation and workshops are the so-called positive displacement compressors. Here, pressure is excited when air is drawn in a chamber and the volume of this chamber is reduced. In this video, we want to confine ourselves to this type of compressors. Let's have a closer look at the reciprocating compressor. As the crankshaft turns, a piston reciprocates within the cylindrical housing. The inlet valve, also called suction valve, allows atmospheric air to enter the cylinder. This is done during a suction stroke of the cylinder. The outlet or discharge valve opens at high pressure during the compression strike. Air heats up when it is compressed. This is a problem of each compressor. The result is not only a less efficient compression cycle, but also to a real danger of explosion if any inflammatory substances, such as oil or lubricant, get contact with the overheated air and piston. Therefore, the compression of a single-stage compressor is limited to an output pressure of about 10 bars, or 145 psi. To achieve higher pressures, you would use a multi-step compressor. Here, a two-stage compressor is shown. The large piston builds the first stage. The air leaving the first stage can now be cooled before it enters into the second stage. With a two-stage compressor, you achieve pressures over 20 bars or 290 psi. Multi-stage compressors with high power also can use water cooling to avoid overheating. Based on its working principle, the reciprocating compressor delivers only pulsed compressed air. Therefore, this type of compressor is used in conjunction with a tank. However, the use of a tank offers the advantage that the compressor can be operated with a two-point controller, resulting in less energy consumption and wear. The diaphragm compressor belongs to the family of the piston compressors. Here, the suction chamber is sealed from the piston by a diaphragm. As an advantage, the compressed air in the compression chamber does not come in contact with the lubricated piston, and thus can be kept free of oil.
The
The
diaphragm.
weak point of a diaphragm compressor, in general, is its membrane itself, since the elasticity is limited. You would use the diaphragm compressor, for example, in the food industry or to fill divers' bottles. A totally different working principle has the so-called rotary compressor, also named as vane compressor.
Compressor. Okay,
A
I'm going to
typical
explain.
rotary compressor has a cylindrical housing. Adjustable rotary vanes with its center point on an offset drive shaft have contact with the housing. So when the shaft rotates, these vanes create chamber of variable sizes. Air is sucked into the largest chamber, being compressed, and leaves the compressor at the smallest chamber. Advantage here is in the pulsation-free flow, in contrast to piston compressors. Therefore, an air tank may be optional. In addition, these compressors are quiet and relatively insensitive to dirt. Typical applications are, for example, wastewater treatment, fish breeding aeration, dust collection, vacuum packing, and so on. Watch also our next videos.
Okay, understood. Actually, the advantage of this piston type cylinder, no, because these are available in wide range of your capacity as well as the pressure. Due to that only, such a piston type reciprocating air compressor, it is widely used in industry also. And one more advantage is that overall efficiency of this piston type compressor are high, okay, when as compared to the other compressor, and very high air pressure and air volume flow rate that can be obtained by using this multi staging of this type of compressor. Okay, and here the better mechanical balance that can be also achieved with the multi-stage compressor. Okay, due to that only two-stage air compressor I have explained. Getting it? So you can combine 2 or up to 60 compressor you can combine. Okay, that is called the multi-staging. Sorry, not 60, 16. Okay. Now let us go for next one. Now lobe type. Okay, under this rotary type uh, compressor, air compressor, we'll go for first globe, then vane and screw. Okay. So this lobe type compressor, air compressor, or it is also called roots blower or rotary type air compressor. Okay, rotary type air compressor. So it's a schematic diagram I have shown here. Please look at on the screen. So this lobe type air compressor, normally it is used in application where high flow at comparatively low pressure is required. No, higher flow at comparatively low pressure is required. In that application, this type of lobe type compressor or roots blower it is used. Okay, and this is there is a practically no volume change. Okay, but impeller of this, what are the this impeller is there, no? Okay, gear type, this is called the lobe. Okay, so from this port air will come. Okay, and this due to the pressure, due to the this force which will act on this lobe, no, due to the air, due to that only this lobe will move. Okay, and this ideal one also move. Okay, or rotate. Then further this air will compress, and from this air outlet port your air will be delivered from that port. Okay, okay, so that lobe that will forces the air through discharge opening is there, no? You can see there. So in this case, pressure developed is a function of your system load. Okay, that means the back pressure. Okay, and here you can see this construction of our lobe type air compressor is shown here. And here you can see this one, this is first lobe, this is second one. Lobe pump we have seen, no, same here lobe type compressor is there. Okay, and air is transformed from the suction side to the this delivery side of the air outlet. Okay, with the continuous rotation of these two lobe, air will be transferred from the suction side to delivery side. Okay, and these lobes are precisely machined. Okay, and this casing also machined to the your close tolerance. Okay, and here only a line of demarcation is, no, you can see here. Okay, here there is a no gap between your this both lobe. Okay, it is normally meshed with each other. Okay, meshed with each other. Okay, so this type of lobe type or the root blower type of compressor, actually it finds its application in the situation where high volume of air is required, but your pressure should be low. Okay, high volume of air wherever required, but pressure is low. That time this lobe type compressor it is used. Okay, then we have this vane type rotary air compressor. Okay, so we have seen vane type air motor, we have seen vane type compressor, we have seen hydraulic motor, we have seen vane pump also we have seen. vent type pump, vent type hydraulic motor, vent type air motor, and this is a vent type rotary air compressor. So function or that operation is similar for everything. Okay, for this all. So air will come from this air inlet port. Okay, then further it will move along with this vents, and when this air will move toward this direction, no, anti-clockwise, that time it will be compressed due to the that spring and vent, and then compressed air will go out from this region, from this air outlet. Okay, so that is a vent type rotary air compressor. Okay, so actually this is similar to your vent type pump, vent gear motor, sorry, vent air motor, vent hydraulic motor. Okay, then we have the a screw pump. Okay, sorry, screw compressor, similar to gear motor. Here screws are used. So screw pump also we have same constructions there. From the inlet port, your air will come here. These are the two rotors are there. This is a male rotor, this is a female rotor. Okay, and this is casing. So when air will transfer from inlet port to this outlet, no, that time it is compressed due to this rotor. Okay, this is called, normally it is called screws. Okay, both screws having the two separate shaft. Okay, and due to the momentum, rotary momentum of your screw, air will be compressed, and from this port, outlet port, you will get the compressed air, and then it is further collected at the receiver, and then from receiver you can take to the your further circuit. Okay, that is a screw compressor. Okay, now let us go for one small again video. Okay.
Welcome to my basic mechanical engineering playlist. Start from the base on, it is double acting air compressor.
Good one video.
And based on sides of piston, based on arrangement, and based on stages. So let's see first one. According to based on sides of piston, air compressor are classified as single acting air compressor and double acting air compressor.
Only I outlet this
Next, based
video.
on arrangement, they are classified as inline compressor and V-shape compressor. Next, based on stages, they are classified as single stage air compressor, double stage air compressor, and multi-stage air compressor. Now, rotary compressor is also further classified as lobe compressor, screw compressor, and vane compressor. Let's see one by one briefly all these types of compressor. So let's start from the base on sides of piston. First one, single acting. In this figure, you can see the single acting air compressor, and this is the animation of the single acting air compressor. They are the reciprocating compressor, which has piston working only in one direction. The other end of the piston is often free or open, from which no work is performed. There is only one side of the compression, that means here it is the upper part of the piston is used to compress the air. The bottom part is open to crankcase and is not utilized for the compression of air. That's why it is called as single acting air compressor. Now next, double acting. Already we have discussed single acting air compressor, and in this figure you can see it is double acting air compressor. So on both sides the compression is carried out. In this animation you can understand on both sides the compression is carried out. That's why it is called as the double acting air compressor. This is also the figure of double acting air compressor. So this is a very simple figure. Definitely you can use it in the examination, either this or this. As from its name, it uses its both sides to compress the air. Here you can see these type of compressors have two sets of suction, or you can say intake and delivery, or you can say exhaust valve on both sides of the piston. As the piston moves up and down or to and fro, both sides of the piston is
Please see
utilized to
how the
compress the air.
single acting and double acting works.
Now next, based on arrangement, it is classified as inline and V-shape. So here you can see inline. The cylinders of various stages are found in a straight line when seen from the top. That's why they are called in inline compressors. Now next one, V-shape. Here you can see V-shape from the side, and here also you can see V-shape. They have concentric valves mounted on each cylinder head unit, which are placed in V-shape. That means at the angle of 90 degree from each other, and may or may not be connected to same crank pin on the crankshaft. Now next, based on stages. First, single stage. So this is the single stage reciprocating air compressor.
This one already we have learned.
Reciprocating
Okay.
air compressor, the entire
Reciprocating.
compression is carried out in a single cylinder. So it is called as single stage air compressor. Next, double
Double one.
stage. In double stage reciprocating air compressor, air is compressed in two stages in sequence. In each stage, pressure of air is increased.
This is called
Here you can see
multi-staging.
two-stage air compressor. Here also you can see two-stage air compressor. Next, multi-stage. So here you can see two-stage, and here you can see three-stage. So you can say it is multi-stage air compressor. In case of multi-stage air compressor, air is compressed in several stages in sequence. In each stage, pressure of air is increased. In a single stage, it is difficult to attain high pressure ratio due to very large size of the cylinder. So at that time, multi-stage air compressor is preferred. Now
Then
it's turn for the
rotary
rotary air compressor.
compressor.
These compressors are not of reciprocating nature, therefore does not have any piston and crankshaft. Instead of that, these compressors have screws, vanes, lobes, and other devices which rotate and thus compress air. Now let's start from the first, lobe compressor, or sometimes it is called as the root blower.
Yes, see, this is a lobe. Okay, see.
In this animation, you can understand the working of air compressor. There are two lobes. Here you can see.
Are you getting understood or not? Are you visualizing, realizing or not this working and operation of the compressors? Please reply me in the chat box. Are you getting or not? Everyone, please reply me in the chat box. Only one student has given reply. Other students, are you getting or not? For more understanding purpose only, I am showing this animated videos. Okay. Already working operation principle of the lobe type, vane type, piston type we have seen, and that single acting, double acting air compressor. Okay, that also we have seen. But to get more information, to realize, to understand how it practically works, for that purpose I'm showing this video. Whether it is useful or not, please reply me in the chat box. Only 2-3 students are giving reply. Other students, are you with me or whether are you doing another work? Okay, thank you.
Attached to the driving shaft by the prime mover. These lobes are displaced with 90 degree to one another. Thus, if one of the lobe is in horizontal direction, the other lobe will be exactly positioned at 90 degree. That means in vertical direction. The air gets trapped from one end, and as the lobes rotate, the air gets compressed, and thus compressed air is then delivered to the delivery line. Here also you can see two lobes.
Or root blower also it is
So
called.
this is also called as the lobe compressor.
Then we have the
Next,
screw compressor.
screw compressor.
See, we have
Name
seen
itself
this.
indicate screws are used to compress the air. That's why it is called as screw air compressor. And this is a very simple figure. Definitely you can use it in the examination, or you can use this figure also in the examination. This figure is only for the understanding of the construction and working of screw compressor. It uses two asymmetrical rotors that are also called as helical screws to compress the air. The rotors have a very special shape and they turn in opposite direction. Here in this figure you can see, with very little clearance between them. So here you can see it is the inlet, then
That
gradually it is
first
moved
how we
from
get the
the right to left side, and then here it is compressed.
then we
Next,
have the
vane compressor.
when
In this figure you can see the animation of vane compressor, and this is a simple figure that definitely you can use in the examination. There is a fixed casing, here you can see, which a rotary rotor disc is placed, which has slots, here you can see, that are used for holding the sliding plates. Whenever rotor rotates, the disc also rotates, and thus allowing the sliding plates to slide,
for
as
the
the inner
when
surface of the casing is eccentric. Here in this figure you can see.
motor, and
Whenever the
here
plates moves away from the center, a huge amount of air gets trapped inside it, and with the rotation, the sliding plates, the trapped air get
that
compressed.
gets
Thanks my dear friends for watching this video. Press the like button to appreciate it.
okay.
Made with vanes or impellers. These types of compressors are called rotary compressors. Rotary compressor and inlet off-center drive rates. The vanes slide in and out to maintain contact with the cylindrical compressor wall. As they do, they create chambers within the cylinder of varying sizes.
Same video, I think
At the largest chamber, as the vanes rotate, they retract, causing the chamber to get smaller and compress the air.
going further, it got
Air
compressed.
exits at the smallest chamber.
Okay, and then it is discharged.
Compressors are typically free of the vibration and pulsation that occurs with reciprocating compressors.
This is a different. Okay, now that how to select the compressor, that point we will discuss tomorrow, and then we'll go for the next, that is a filter, regulator and lubricator, that is FRL unit. Okay, understood whatever discussed till, whether understood or not? Okay, now I request all of you, please write down your roll number in the chat box and you can leave this meeting. Okay, thank you. All of you write down your roll number in the chat box, and then only you can leave this meeting. Hurry up, be fast. Okay, and then join your next lecture. Remaining students, be fast. Ajit, Gaikwad, Gaurav, Viraj, Ruturaj, Rahul, Sainath, Saurabh, be fast. Gaurav, Ajit, Saurabh, Rahul, Sainath, Ruturaj. Hurry up. I am ending this meeting now. After ending, there is no provision to write your attendance.